Okay, welcome to the next lecture. Already we have seen three different methods for environmental monitoring. Today we are going to learn another method, that is X-ray fluorescence method. We are focusing only application of this method towards environmental analysis. So environmental analysis, this can be successfully used for monitoring of particulate matter, monitoring of minerals or materials present in environment, that is from soil, from air. This can be easily used method, X-ray fluorescence. So the first we will see what is mean by X-ray fluorescence, and another part, that is what is exactly mean by application of this in environmental analysis. So the first we will see what is exactly X-rays are used for monitoring of particular matter. So here we can I will show you the first what is meant by X-rays. Okay, so already we know X-rays are nothing but electromagnetic radiation. So normally having 10 raised to minus wavelength, 10 raised to minus 8 meter to 10 raised to minus 11 meter, and energy is normally 100 kilo electron volt. So, this is range electron volt. So this normally very high energetic rays. Okay, so I'm not going into the details how these X-rays are discovered, who discovered the X-rays, because in next semester we are having one major topic, that is X-ray spectroscopy, where we can learn in details how these X-rays are known. But basically I'm focusing on X-ray fluorescence. So why this is X-ray and why it is a fluorescence. So already we have seen in what is meant by fluorescence. So fluorescence is nothing but the emission. Okay, so for this emission the first step must be absorption. So now these are X-ray fluorescence, so where the first X-rays are absorbed by a particular sample and they emitted again the secondary X-rays, and that's why it is termed as X-ray fluorescence. So simple, I will show you in a diagram. So the next, if we observe this particular triangle, so this one is nucleus and these are the K shell, L shell, then M shell, and these are the electrons. Okay, these are in K shell, these are in L shell. So instead of very high energetic incident X-rays are used, so which gets, so as these are very high energetic, they penetrate through the shells and toward this K shell electrons. So because of this high energy they eject out these electrons. Okay, so now there is a generation of hole, and this one is now filled by the neighboring L shell electron. Okay, so if it is filled by L shell electron, it is termed as alpha X-rays, and if it is filled by M shell electron, it is termed as beta X-rays. Okay, so this, remember this simple. In next semester we will see how this actually nomenclature alpha and beta. So while filling this, the energy gap, and this energy gap is radiative energy, and these are termed as X-ray, secondary X-rays. So that's why the X-ray, how this X-ray gets generated, and the same principle is used. And now why this is X-ray? So suppose this is a copper material and high energetic X-rays are incident on this material. So by this mechanism is X-ray are gets emitted. Now these secondary X-rays, these are characteristics of copper. So while analyzing this particular wavelength, we can easily term that this of copper. Similarly, if zinc is, it gives the characteristic of zinc secondary X-rays. If this is of iron, it gives characteristic of iron secondary X-rays. So that's why this analysis is used in environmental analysis. Any metal we can be easily analyzed by X-ray fluorescence. We will come towards the diagram of this. So this is X-ray tube. So X-ray source, any that is cathode source or radiative X-ray generation source, this can be used, or scintillation source we can be used for generation of X-rays. So The X-rays are generated through this tube or collage tube can also be used for generation of X-ray. So X-rays are generated. They are now focused on sample. So this is now the sample holder where we keep our sample to be studied. Maybe it's solid, maybe it's air. So this is mounted on a particular support. Now the X-rays are incident on this sample. So this collimator, so fine beam of after colliding with this sample, this secondary X-rays as per the previous method already previous slide we have seen how this secondary X-ray gets generated. So these are primary, now the secondary gets generated and through this collimator they are inserted on crystal. Now why this one is used? For diffraction. So these get diffracted at various angles on the crystal and monochromatization can be achieved, dispersion can be achieved, and this dispersion we can, because at particular different wavelength they get diffracted, depends on the characteristics of the particular sample. So these are now again finally go through collimator and now these are detector. Various types of detectors are, gigamolar counter is there, then scintillation counter is there, proportional counter is there. Okay, so different types of detector can be used for measurement of X-rays. Its wavelength and its intensity is measured. Okay, so very simple techniques which can be used for X-ray fluorescence, termed as X-ray fluorescence. So this one is typical table mount X-ray fluorometer. So this one is pan analytical X-ray fluorescence spectrometer epsilon 1. So this one is table mount, simple instrument is there, so we can easily use for measurement of X-ray. Okay, so already we are coming towards end. So now this one is how environmental analysis. So multi-element fluorescence from cadmium 109 source we can carry out. So within a single run we can analyze different elements present in that particular sample. Okay, we have used cadmium excitation source and by using this we can analyze different metals which are present in that particular sample. So this one is very helpful techniques, and already this one data I have taken from the source where this one is soil analysis. I am sharing the PDF file with you where you can see the details. Okay, so as in PPT this is not visible, but this from the soils how the different metal parameters are analyzed by using this X-ray fluorescence techniques. Okay, so this is very widely used technique for determination of particulate matters present in environmental analysis. So it can be effectively used, X-ray fluorescence. So I will share this PDF file from where I have taken this particular image for soil analysis. So learn this particular file where you will get the initial details of also X-ray productions, its applications in XRF and many other applications which detectors are used for X-ray analysis. Okay, so learn this particular PDF file. Thank you.